So how many of you have heard of a function before? Most of you? Okay, function. We have been graphing functions for a while. We call them lines a lot of times, but they are in fact functions. And today we're going to talk about what really makes something a function and what we need to look at to start with today. So let's just think about a function. What is your function in this class?
Not falling asleep.
Not falling asleep. Good. Paying attention during the lesson, learning how to do it, and practicing it. That's your function, right? Now, do you guys do that every day? Sometimes yes, sometimes no. If you truly were a mathematical function, you would do the exact same thing every single time.
Yeah.
Okay? And that's what, and there's a couple in here that you guys are truly doing a function. Not everyone the good function, but we're all doing the same. You're very consistent. And that's how a function is. A function, if you put something in, the same thing comes out every time. Okay? I'm a farmer. I get on my tractor, hook up the baler, go start baling hay. Loose hay goes in. What do I want to come out the back? Baled hay, right? That's the function of that baler, right? If it's not doing its function, if it's not consistently putting out bales, then we have a problem, right? Okay, if I loose hay's going in, baled hay comes out, loose hay goes in, piles of loose hay go out, loose hay goes in, puppies go out. That's not good, right? Okay, so a function, what? How did that happen? I don't know. It was a weird day. Anyway, a function is only a function if every time you put something in, the same thing comes out every time. And so a function looks something like this. This is probably the easiest way to explain it to you. So with a function, if I put a number like 5 in, every single time 6 comes out. Every time. So tomorrow I go back, I put a 5 in this function, 6 comes out. Every single time. And that's what that means right there. Okay? I put a 4 in, and 8 comes out every time. I put a 0 in, a 2 comes out. This is what a function will look like. For every input, there's exactly one output. Okay? So, let's look at this one for a minute. This one confuses us often. So I want you to think about the definition again. For every input, there's exactly one output. It's consistent. Every time I put a number in, the same number comes out every time. Do you think that's a function?
Yes.
Every time you put a 2 in, what comes out?
20.
Every time you put an 8 in, every time you put, do you get it? This one's a function. Okay, it's consistent. Now let me show you one, I guess, that would not be consistent. See the problem here? Yeah, this wouldn't be, like if you put a 5 in and an 8 comes out, and then later you put a 5 in and a -3 comes out, well that wouldn't be good, would it? No, you want it to be consistent, okay? So this one is not a function. So that's what you'd be looking for. Sometimes they give you the problem like that. Sometimes they'll give it to you as ordered pairs. So they'll just give you a bunch of ordered pairs, or I'll give it to you this way. Okay, you look at those ordered pairs. What do you think? Is this a function or not? No. Why not? Where's the problem?
There's 2 5.
Right? You put a 5 in, 0 comes. So you're going to be asked, is it a function or not? And if it is, you're going to say, yeah, for every input there's one output. Or if it's not, you're going to say, no. You put a 5 in, you get a 0 out. You put a 5 in, you get a 10 out. That's the problem with it. It's not a function. This game pretty simple. function, not a function. Okay? Turn to page 104. Down at the bottom of page 104, you'll see a monitoring progress section. Do you see it? Okay. Can you all look at number 2 and just kind of make up your mind whether you think that is a function or not? So number 2, it's kind of on the bottom right of page 104, and then I'll see whoever has the most fear in their eyes, I'll call on you in a minute. I got to look at it. All right, let's see. Gracie, what do you say? Function? Not a function. Not a function. Where do you see a problem?
There's not the same number of each of the, I don't know.
Well, if you put in a -4, what always comes out? And if you put in a -2, what always comes out? Sorry. If you put in a -1, what comes out? 2. You put in a 2, what always comes out? And you put in a 5, what always comes out? So what do you guys think? Function, not a function? Function! Okay. Look at number 3, input-output table. Does that make sense that we call the X the input and Y the output?
Yeah.
That's like when we're graphing, right? We put a number in for X, we get something out for Y. What do you think about that input-output table? Function. Yeah. How about number 4?
No, maybe so.
No, because you put a 1/2 in, and sometimes a -2 comes out, and sometimes a 0 comes out, and sometimes 4 comes out. That's not a function. Does that make sense, everybody? Okay. Okay. So that's the whole function, not a function thing. Now, sometimes on a graph, we can talk about function or not a function. Let's see. Linear equations. We graph something like this. Okay? For every 1x input, look, I put a 0 in, what comes out every time? Right there. Right? If I put this number in, that number comes out every time, doesn't it? So these are linear functions, not just linear equations. They are functions. Let me show you one that would not be a function. So some equations, when you graph them, they give you this kind of shape. Okay, so let's think about this one for a minute. If I put this x in, what can y be? Can it be this number?
Yeah.
Or can it be that number up there? There's 2 different possibilities, aren't there? Okay, so this one is not a function, and it fails what we call, let me write this, the vertical line test. If I can draw a vertical line and hit the graph more than once, that means that for 1x there are more than 1y. Now don't get too crazy on me. Sometimes people are like, but Mr. Collard, I can draw a line here and only hit it 1 time. Or I could draw a vertical line here, and how many times am I going to hit it? 0. But so listen carefully to the vertical line test. If you can draw a vertical line and hit it more than once, then it's not a function. You understand? Okay. So let's think about the 2 you graphed today. Are they both functions?
Yes.
Yeah, they are. Okay, they pass the vertical line test. Now there's lots of graphs, lots of equations that when we graph them, they give us some kind of shape. Some look like this. What do you think? Function, not a function?
Function. Yeah, it has to be a function.
Yeah, it's a function. Okay. Some equations look like this. Not a function? Now see how you can draw two lines, and for one x there are two different y's, right? Okay. Some look like this. And they just continue on forever. What do you think about that one? Function or not a function? Yeah, it's called the sine function, okay? Or cosine. I think that's the sine. Okay. So it's pretty easy to look at a graph and to tell whether something is a function or not. Let's look over on page 105 for a minute. Example 2a. You see 2a? Example 2a? Just has some dots on the graph, doesn't it? Okay. So what are you guys thinking about that one? Do you think that's a function or not?
No.
Yeah. Yeah. When you put a 2 in, what comes out? A 2 or a 5? What happens when you put a 5 in? A 1 or a 5? There's two different possibilities, aren't there? Okay? So, do you understand why that one's not a function? We all good? Stetson, got this? Pretty basic idea, right? Function, not a function. Okay. Let's look down at the bottom of page 105. Number 5, is that a function?
Yes.
Number 6?
Yes.
Number 7?
No.
Number 8?
Yes.
Okay, you got it. Okay, simple concept. Okay, turn the page. Now we talked about an x and a y. We talked about x is the input and y is the output. And we've done a lot of this kind of stuff. 1/2 x plus 3. We always put numbers in for x, don't we? And then we get numbers out for y, like that. I put a number in for x. Half of 2 is 1, plus 3, that's 4. I get a number out for y. How many times have we done this? 100 times so far this year? 100 times. Put a 10 in. That's half of 10 is 5, plus 3, that's 8. What's going to happen if I put a 10 in again? Yeah. So if I give you guys this one and say put 10 in, you're going to do it 20 different times. 20 different people are going to do it. And all of you are going to get the same output, aren't you? Okay? All right. Yeah. Theoretically. Okay. Now, so we call this the input and the output. We also call this the, let me write this. You're going to want this in your notes. We call the x the dependent variable, and we call y the independent variable. And we'll talk a little bit more about that in a minute. And we also call x and y, we call the x's, we call them the domain of the function. Who's heard of domain before? And what's the other word I'm going to say now? Range. Good. The range. That's all the y's. So x and y, input, output, domain, range, dependent, independent variables, all kind of the same thing. Let's talk about the domain and range. You're going to be given a little function like this with some inputs and outputs, and you're going to be asked, what is the domain of this function? Okay? And the domain is simply the set of numbers that go in. So you write it like a set, you make a little brace like that, and you say, well, what numbers go in? And that's the domain of the function. That's how you answer the question. There's the domain. So guess how we do range, Gracie? Gracie's on it. What numbers come out? 3, 4, and 8. There's the range of the function. Okay? And that's all we have to say. All right. Let's let's do this. I'll move that up so you can't see it now. I'll just give you some. Some points here. Okay, first of all, is this a function? Now don't jump to conclusions. Think first. For every input, is there one output? Every time I put a 9 in, what comes out? Okay. Every time I put 7 in, what comes out? Every time I put 2 in, what comes out? Every time I put 9 in, what comes out? Is that a function? Yes, it is. Because every time I put 7 in, what comes out? So I can have the same output for different inputs. The big thing here, though, is every time I put a 2 in, what comes out? A 3.
I'm so confused.
I know. I knew this one was going to confuse you. I did it before, but I knew I'd get you on that. So I put a 9 in, negative 6 comes out. I put a 7 in, 3 comes out. I put a 2 in, 3 comes out. Okay. This is a function because for every input, I get the same output every time.
But you don't. I'm so confused.
Okay? So, let me show you when it wouldn't be a function. I put a 9 in, I get a negative 6 out. I put a 7 in, I get a 3 out sometimes, but sometimes I get a 6 out. This would not be a function. Because when I put a 7 in, am I sure what's going to come out? No. But on this one, every time you put a 7 in, are you sure what's going to come out?
Yes.
Yes. Every time you put a 2 in, do you have no doubt what's going to come out of the function? Okay. This one.
You wouldn't know.
Wait a minute. Every time you put a 9 in, what comes out? Whoa. Every time you put a 9 in, what comes out?
Negative 6 or 7.
Yeah.
No, we're talking about... Oh. I didn't see that.
Okay, that
Crap!
makes more sense. That makes more sense.
We
There
beat
go.
you this time.
You won! You totally won! Oh, I was just throwing random stuff out there, and my randomness came back and bit me in the butt. Okay, 4, 6, 5, 2, 7, 6, 9, 10. Okay. Function?
Yes.
Oh! Okay. Reagan was going to punch me in the head. Okay, that one is a function, yes, because even though we have the same outputs here, we're sure when we put a 4 in, when we put a 7 in, we know it's going to come out. Okay, all right. So tell me, what was the one I wanted to do? Okay, so domain. Now you have to write the answer. The domain has to look like this. It's a set of numbers. Okay, so what is the domain of this function?
4, 5, 7, 9.
Oh, you guys are so smart.
Sounds like an area code.
It kind of is. Okay, the range of this function. What happened to the other 6?
They combine.
There is no other 6.
Wait.
There is only one number 6. Isn't there?
Yeah.
George, are there 2 different number
I
6s?
remember that someone told me this early in elementary. They said the way to remember this is like X is the boy and Y is the girl. X can only have one girlfriend, but Y always has a bunch of boyfriends. I remember that.
I don't know if that's true or not, but if that helps you, then I'll go with it. Whatever it is. Yeah. Okay.
Nice, I hope.
Yeah, there's only one number 6. Okay, so you don't have to list it in here twice. They don't necessarily have to be in order, okay, of how they go in or how they come out. It's just the numbers that go in, that's the domain, and then the numbers that come out are the range. Okay? All right. Now, let's look at example 3 on page 106. Now we're going to get a little bit more difficult here. We're going to talk about the range. Can you guys see example 3A has 4 dots? Can you see those 4 blue dots?
Yep.
Okay. Tell me what X can be. Like, look at the furthest dot on the left.
3472.
Wait.
Negative 3.
-3,
Negative 1.
-1,
Positive 1. And
+1,
positive 3.
and +3. Those are the x values. Does that make sense? Okay. And then the range, that's the y values. So look at the point furthest on the left. What is its y value?
Negative
-2.
2.
Keep
Zero.
going. What's the next one?
0.
0. Next one?
2.
2. And then the next one over?
Positive 4.
+4. Okay, that's pretty straightforward. We can see, okay, the x are, you know, here's the x's. If I just go at the dot and I look to the x-axis, or if I look at the dot and look at the y-axis, that's my domain and range. I've got it. But look at B. See this? See the kind of little squiggly line there? Goes up and over and then up. Okay. There aren't a set number of things x can be here. Because when I look at that, can x be -2?
Yeah.
Can it be +3?
Yeah.
Can it be a 0?
Yes.
Can it be a 1?
Yes.
A 2?
Yes.
How about a 4?
No.
X can't be a 4, can it?
No.
Can it be a 1.2?
Yeah.
Can it be a 0.9?
No. Wait, yes.
Yes.
0.9? Can it be -0.9?
Yes. X can be.
Can it be -1.9?
Yes.
So do you see how many different x things can x be? Can be a lot of them, can't it? And so when we express the domain in this case, you can't just say, well, it's this number and this number and this number and this number. You can't do that. All you can do is say, okay, what is the lowest value x can be as we look at the graph? The lowest number x can be -2. What is the highest value x can have? Positive, is it +3? Yeah? +3. And I put x in the middle, and what did both the alligators do? Okay. And does the end of this line have open circles or closed circles? Huh?
Close.
Closed. So there are the x values. Anything from -2 up to 3. And how many different numbers are there between -2 and 3? Yeah, infinitely many,
Yeah.
right? Okay. Now let's talk about the range. So now we're looking at the up-down of the graph, right? The range is the up-down. What is the lowest the y value goes?
Negative 1.
Okay? And what is the highest the y value goes?
Positive 2.
Okay. Now, we're not going to put x in the middle here. What are we talking about? Y. And what do both the alligators do? Eat the big number. And are we talking open circle or closed circle? So it can be equal. Y is always greater than or equal to -1 and less than or equal to 2. And this is more of a realistic kind of domain and range. Usually it's not like you can only do this. You can only do this. Okay? Let me give you an example. Okay. You guys ever ride in a taxi before?
Nope.
No? Some of you have? Okay. So a taxi might look something like this.
Me neither.
Okay. So this is an equation that determines how much you have to pay for your taxi ride. Okay? And one of the biggest problems with it is we have x and y in this equation, and x and y have nothing to do with this problem. Does riding in a taxi have anything to do with xylophones and yaks?
No.
No. What does it have to do with?
Price.
The money.
How fast do you get there? Miles. How
Uh,
long is the person drive? It's distance.
what do you mean how long? Like how many minutes?
Oh, no, like how far they drive.
There you go. It's distance, how far they drive you, and how much you have to pay. Okay? That's the two variables. Okay? And so this one is actually distance. And this one is actually how much you have to pay for the taxi ride. Okay? So you get into taxi, you say, take me to Madison Square Garden. And he says, okay, how far have you gone so far?
Like,
0.
How much does it cost you so far?
Zero.
$2. Costs you $2 before he even puts it in drive and starts to go. Okay, and they do that because sometimes someone might only want to go a couple blocks, you know, and it's not really worth it to pick somebody up and take them a couple blocks for, you know, $2.50 a mile. Okay, so they charge you an initial amount. You'll find that a lot. On your phone, you pay so much a month plus so much money for depending on how much data you use, correct? If someone comes to your house to fix your dishwasher, they'll charge you $50 just to show up and then $25 an hour. Okay? Because they might show up and look at the dishwasher and be like, oh, it's this. You need to plug it in or something. And it might take 5 minutes. Do they want to drive to your house and go in your house and get all their tools out of the truck and come in and look at the dishwasher and get paid to work for 5 minutes? Yeah, that's not worth it, is it? Okay. When I was a kid, I had a little tractor with a tiller and a backhoe on it and a front end loader. And my dad would send me to people's houses to do jobs. And at first, I charged $20 an hour. But that was horrible because he would say, drive to this old lady's house and till her garden for her today. So it would take me, this thing, like, you can literally jog faster than it would drive, okay? So it would take me like 20 minutes to drive over there, 20 minutes to till the garden, and 20 minutes to drive home. So it would take me an hour to do it. Well, how much did I get paid for?
$20.
Yeah, just the 20 minutes I was working. A third of an hour. A third of $20. What is a third of $20? $6.50? You're gonna go, okay, close to that. Okay, good. Okay, well, that wasn't worth it. So I started charging $20 plus $20 an hour. So when I showed up at your house, how much did it cost you? $20 plus $20 an hour. Okay, and that's the way I would charge it. Okay, so anyway, we go a mile. What's this going to cost us? That looks like a 6. Sorry about that. Was it? How much?
$4?
Yeah, $4.50. Let's go another mile. 7. Okay. Do I have to just go 1 mile or 2 miles? No. Can I go 3.76 miles?
Yeah.
Probably. Maybe they round that off and say it's 3.8 though. Maybe they only charge it to like the nearest tenth of a mile or something. Okay? Which is probably how it actually works. But there's lots of different inputs, right? It doesn't just make sense, I want to go 1 mile, or I want to go 2 miles, or I want to go 3 miles. Okay? They do that. Can you get in the cab and be like, drive me to Los Angeles?
Yes.
Well, it depends on where.
Now that only happens in the movies. No cab driver will take you to Los Angeles from New York. Well, maybe if you gave them a giant bucket full of money right off the bat. Been like, here's $20,000. Drive me to Los Angeles. Maybe they'll do it for that.
Lifetime worth sometime.
Okay, so let's talk about this. Dependent, independent. Oh, I wrote them backwards. I should have did it this way. Hold on a minute. You almost won again.
Ah.
In this case, I'm going to call it the distance you drive. That's independent. Can I get in and say, take me wherever I want to say? That doesn't depend on anything.
Wait.
But the money I pay.
Isn't X
Wait, isn't
dependent?
Oh, so the X is the independent variable,
That's not what you told us earlier.
isn't it?
You told
You
us
told
that
us
it
X
was
is
different.
Are you kidding me?
Yeah, you did.
Oh, poo.
Huh.
Let's change this.
Still one.
Oh,
I wasn't going to talk to you about it right then, and then I just hurried and wrote it down for some reason, and let's fix that. Well, why is the x the independent variable?
Because it can do whatever it wants. And
Yeah, we can
y
put-
is-
yeah.
Is how it turns out.
Yeah, just like when we're graphing. Here, can I put any number I want in for x?
Yes.
Yeah, it's independent. I can do whatever. But what comes out for y depends on
What you put for x.
exactly what we put for x. So let's talk about our cab drive. Distance I travel, independent. I can say take me wherever I want to go, right? Within reason. The amount I pay though, it depends, right? Okay, so that's our dependent variable. Well, gosh, I think we got through this lesson. I only screwed up twice, so that's a good day, right? Nicole? Yeah? Yeah? Okay. All right. So, problems that you're going to do on today's assignment. And you do have time to get this done in class. It doesn't take very long. It's nice and easy. Chapter 3.1, I expect you to get done in class, okay? Okay, I'll try not to be wrong twice tomorrow. I'll try to cut it down to once. That good, Tommy? Yeah. Thanks, Cooper.